In this video, we're going to look at hyperbolas. We're going to locate hyperbola vertices and foci. We're going to write the equations of hyperbolas in standard form. We're going to graph hyperbolas centered at the origin and not centered at the origin. And then, of course, we're going to do some applied problems involving hyperbolas. So hyperbolas are used in lots of places. One of the places you may see them is in the cross-section of an amphitheater. It's actually a part, one branch of the hyperbola. Nuclear cooling towers are also hyperbolas, and comets that come around a planet once and then don't reappear would be a hyperbola-shaped path, unlike some of the comets that come around more than once. Those are elliptical. So what is a hyperbola? Well, we're going to define a hyperbola as the set of all points in the coordinate plane, again, xy plane, and that the differences between the distances x and y and the foci is always a positive constant, slightly different than the way that we look at an ellipse. So as we take a look at a hyperbola, there's lots of pieces to it. We have something called, this is the transverse axes. I like to think of that as the axes in which my hyperbola is going to hug. We have the conjugate axes, that is the axis in which I don't hug, my hyperbola does not hug. We have the vertices, and now we have co-vertices instead of the minor and major vertices. We have just major vertices and then co-vertices. We also still have a center, just like the ellipse. We still have foci, just like the ellipse. But we also picked up something called these asymptotes, and so we will talk about those. If we start with the hyperbola centered at the origin, our foci being negative c and positive c, comma 0. The hyperbola is a set of all points in which the distances are a constant. So this is what it means. The difference is the distance, not the sum. Ellipses are the sum. Now notice here's d1, d2. So if I take d2 minus d1, this would be the exact same value. If I call this a d3 and this d4, it would be equal to d4 minus d3. So notice that I still have some a's here, I still have some c's here. I don't see a b, but we're going to talk about how to find the b and how it actually is part of the graph. Using our usual algebra and distance formulas, we end up with our first standard equation of a hyperbola centered at the origin. Now, the transverse axis is always going to be hugging, this is how I always remember, it's going to be hugging the positive, right? Because you want to hug positive people, you don't want to hug negative people, because that just could be unpleasant for everyone. So notice how the x is positive, the y is negative. That's a real difference between ellipses and hyperbolas. Structurally, is that it will always be a plus between them, whereas hyperbolas, one of them would be a plus and one of them will be a minus in front of that term. Now notice that the x is the positive one, and so my transverse axis is along the x-axis. And then, of course, when we move off the origin, that if the x is positive, then my transverse axis is going to run parallel to my x-axis. My vertices are at negative a0, so that's just exactly like the ellipse. My foci are negative c0 and positive c0. However, what changes is how I find c. Now, c is back to our regular Pythagorean identity. C squared is equal to a squared plus b squared. And we pick up these asymptotes. Now, I personally don't ever remember the asymptotes, and I don't want to take the time to remember them because I'm just going to do a counting, right? I'm not going to worry about this. I'm just going to count. The length of the transverse axis is 2a, just like the length of the major axis in an ellipse is 2a. The length of the conjugate axis is a 2b. Just like the minor axis was 2b, and the distance between the foci is still 2c. Both ellipses and hyperbolas, those are all the same. Now, what I said is I don't worry about the asymptotes, and the reason I don't is because I start here at the center, and I know that this distance is delta x, and this distance is delta y, and so my slope is delta y over delta x, and I just count. And I call this my box. When we start graphing these, I'm going to explain more about the box and the importance of when I graph the box. Similarly, when I have my y, notice how structurally this is exactly as up above, but now it is the y that is positive, and notice that my transverse axis is going to be running parallel or on the y-axis because the y is the positive one and x is the negative one. I don't really pay a lot of attention to the a and b because what we needed with ellipses, the a had to be underneath, the a was the larger number and it had to be underneath the one in which was my major axis. Well, a is still underneath the transverse, but we don't have to have a be in the larger number. So that's something to pay attention to. Same old, same old. Now let's go ahead and take a look at graphing this and finding all the important pieces of my hyperbola. So first of all, it's not in the right form, so I need to divide everything by 4. That's the first thing I'm going to do. So I'm going to get x squared over 4 minus y squared over 1 is equal to 1. I know my transverse axis is going to run along or equal to the x-axis, not because the larger number is underneath the x, but because the x is positive. So this is how I draw my hyperbola. I know from the center, in this case happens to be 0, 0. I still have to take the square root of 4, which is 2, and it's underneath the x, so I'm going to go 2 in each direction. And then I know that's where my vertices are, so here's where my vertices are. Here's where my center, my vertices. I look to see what the value is underneath the y squared, and it happens to be 1. So I'm going to go 1 in each direction for the y. I'm then going to draw a box that is one distance away parallel to the y-axis, and 2 distance away running parallel to the y-axis. And this is my box. Now, if this was an ellipse, I would draw my ellipse inside of this box. But it's not an ellipse, it's a hyperbola. So what I do is I draw my asymptotes corner to corner through the center. I know the location of my vertices, and I also know that it's going to run along the asymptote and touch my vertex. So there's my graph. Now, if I want to find my asymptotes, I'm just going to count. I went 2 in that direction, so my delta x is 2. I went 1 in that direction to get to this corner, so my delta y is 1. So my slope, m, is going to be positive and negative 1 over 2. That tells me my asymptotes are y is equal to plus and minus 1/2 x. And that's it, right? I am just literally counting from the center to the corner of my box. Now I still need to find my foci. So my c squared is equal to my a squared plus this time my b squared. So my c squared is going to be equal to 4 plus 1, which gives me 5. That tells me that c is plus and minus the square root of 5. So here's where my foci are. They're being hugged inside the parabola. And this foci, because the x is changing, it's going to be the negative square root of 5, 0. And this one is going to be the square root of 5, 0. And I have found and labeled all my parts. Let's take a look at my next one. I'm going to go ahead and divide by 81. And so I'm going to get y squared over 9 minus x squared over 81 is equal to 1. Now notice that my larger number is underneath the x. But my y is the one that's positive. So my transverse axis is going to run along the y-axis. My center is still 0, 0. So here's my center. I'm going to get ready to build my box. So I'm going to go up 3 in the y direction. And I'm going to plant my vertices, right? So my vertices are 0, 3 and 0, negative 3. So I planted my vertices. In the x direction, I'm going to go 9. So here is 9, not draw to scale. Here is negative 9. And I draw my box. Again, if this was an ellipse, it would be contained within this box, but it is not. I'm going to draw my vertices, not my vertices, my asymptotes, through the corners and the center. My delta x, from center to the edge of the box, my delta x is 9. My delta y is 3, so I know my slope is going to be positive negative 3 over 9, or in other words, positive and negative 1/3. So I know where my vertices are, I know where my center is, my asymptotes are y is equal to plus and minus 1/3 x. The only thing left to find is my foci. Oh, and I do need to draw it. So let me draw it. With my drawing, I'm going to go along the asymptote, touch that vertex, and then continue along the asymptote. I'm going to go along the asymptote, touch my vertex, and then come back around on that asymptote, approaching the asymptote, but never actually touching. My c squared is going to be equal to, it is 81 plus 9. So my c squared is going to be 90. So my c is going to be 3 root 10. So my vertice, or my foci, here's my foci. My foci down here is going to be 0, comma, negative 3, the square root of 10. And this foci up here is going to be 0, comma, 3, the square root of 10. All right, I have a couple of more. My next one, I'm going to go ahead and divide by 1/4. So I have y squared divided by 1/4 minus x squared divided by 1/4 is equal to 1. And I'm going to leave it just like that. Now, what I know is that the y is positive. So when I go to draw this, my transverse axis is in the y. And I know from the center, I'm going to go the square root of 1/4, which is 1/2. So here's where this is. This is my vertex. It is 0, comma, 1/2. And I come down here and I have my other vertex, which is 0, comma, negative 1/2. From the center, I'm going to go 1/2 in the x direction in both ways. So 1/2, negative 1/2 and positive 1/2. And draw my box. Again, if this was an ellipse, actually, if this would be a circle, because the box is perfectly square this time. And I'm going to draw my asymptotes that go corner to corner through the center. My delta x is 1/2. My delta y is 1/2. That tells me my slope is going to be plus and minus 1 because they're the same. So my asymptotes are y is equal to plus and minus x. We'd like that. Last thing I need to do is find my foci. So I need to find c squared. C squared is going to be 1/4 plus 1/4, which is 1/2. So c is going to be plus and minus the square root of 1/2. So my foci is going to be here and here. And so my foci is going to be 0, comma, and we know we can rationalize this to be negative square root of 2 over 2. And this one, which is 0, comma, square root of 2 over 2. My last one here is also going to be a nice box. Divide everything by 3, and I get x squared divided by 3 minus y squared divided by 3 is equal to 1. That tells me, and the x is positive, that tells me my transverse axis is along the x-axis. So I'm going to go out the square root of 3 in both directions from the center. So right here and here is my vertex. So those are my vertices. I also know I'm going to go the square root of 3 in each direction in the y to build my box. I also know I'm going to go ahead and draw my asymptotes corner to corner through the center. Again, my delta x and delta y. My delta x is equal to the square root of 3. My delta y is equal to the square root of 3 from the center to the corner. That's how I find my slope. So my slope is, again, plus and minus 1. So my asymptotes are y is equal to plus and minus 1. We like that. Lastly, I just need to find my focus. So c squared is equal to 3 plus 3. So c is equal to the square root of 6. So my foci are here and here, which is going to be the square root of 6, comma 0 and negative square root of 6, comma 0. And that's it. And notice I'm not ever referring to any of the formulas. I don't have time to memorize them. Even if I have them in front of me, I don't have time for that. Now, you're saying, but what happens when I'm off the center? Well, not really much. I'm still going to be counting. When I find my slope, I'm going to be counting. This is my delta x. Here's my delta y. The only thing that really changes is I'm going to use the point slope, the modified point slope. I'm going to say y is equal to m, x minus x naught plus y naught, where my x is going to be my h part of my center, and the y naught is going to be the k part of my center. And that's it. That is literally it. So everything else stays the same, everything like we expect. And of course, if we're going in this direction, nothing new there. Okay, now let's focus in on these problems. We need to find all the bits and pieces. So as before, I'm going to rewrite it so my x terms and y terms are together. I'm not going to change my signs. So I have x squared minus 2x, y squared minus 4y. Move that 4 to the other side, the constant. Now I'm going to rearrange it. So I have x squared minus 2x plus something. Now, if you remember from my video on ellipses, if that coefficient on the y squared or the x squared is not 1, I better factor that out. So I'm going to factor out a 1, negative 1, so it leaves me positive y squared, but that changes the sign to a positive 4y plus something. That equals 4. Now I'm going to do this in red, so I'm going to add that blank, and I'm going to do this in blue. So I'm going to do negative 1, because that's the coefficient, times that blank. And as before, we know that we're going to take this negative 2x, divide by 2x, we get 1, or negative 1, we square it, so we add 1 here and 1 here. This then becomes x, get rid of that squared, x minus 1, the quantity squared, minus, and then, of course, I'm going to do the same thing here, 4y divided by 2y, which gives me 2, so I'm going to add 4 here, and then 4 here. So I end up with y, and I have plus 2, the quantity squared, and this ends up becoming 1. Now this is already in the correct form, the standard form, and I can write it, if I'm not like, what? I can write it over 1, absolutely can write it over 1. So now I'm ready to do the graph. The x is the one that is positive, so that is my transverse axis. Now, it's going to run parallel. I need to go from my center. My center is 1, negative 2. So I'm going to go 1, negative 2. So here's where my center is. From my center, now I know the x is positive, so this is where my transverse axis is going to run. From my center, I'm going to go 1 in each direction to find my vertex. So here is a location of my vertex, and here's a location. So my vertices are going to be 0, negative 2. And 2, negative 2. So I found my vertices. I'm now going to draw my box. My box is going to be 1 in the y direction. So I'm going to draw this box. Here's my box. Here are my asymptotes. Here is my hyperbola. Along, touch, come back along. Along, touch, come back along. Now, found my vertices. I need to find my foci. So c squared is going to be 1 plus 1, so that's 2. C is equal to the square root of 2. Here's where my foci are. My foci are going to be my x part, which is 1 plus the square root of 2, negative 2. That's plus and minus down here. And this is going to be 1 minus the square root of 2, negative 2. So there's my foci. My asymptotes are the last things that I need to find. And again, I'm going to count. I went delta x1, I went delta y1. My delta x was 1, my delta y was 1. So my asymptotes are going to be y is equal to plus n minus 1, x minus my center part. Notice this is going to be x minus 1. And then my y part, which happens to be negative 2. And there is my asymptotes. Here is my vertices and my center. Here's my foci. And of course, my graph. Let's take a look at B. Once again, I'm going to rewrite this as 36y squared minus 24y minus x squared plus 6x is equal to 41. So 36y squared minus, we're going to have a fraction here, aren't we? We're going to have 24 over 36y plus something minus 1 x squared minus 6x plus something is equal to 41, and then it's going to be plus 36 and this first blank, and then minus 1, that second blank. So we know that 24 over 36, this is going to reduce to 2/3. So I'm just going to erase this and write it as 2/3. So write this as 2/3. Now remember, to find that blank piece, I need to do 2/3 y divided by 2y. So I can figure out what my y value is. And when I do that, I get 1/3. So I know I'm going to put in 1/3 the quantity squared here, and 1/9, or in other words, 1/3 the quantity squared there. That tells me that this is going to become 36, and then here I'm going to get y minus 1/3 the quantity squared minus. I'm going to take this negative 6x, divide by 2x, I get negative 3, so I'm going to add 9 here and 9 over here. So then this becomes a negative 1, x minus 3, the quantity squared, is equal to. I have 41 plus 36 multiplied by 1/9, which is 4. So I have 45 minus 9, which gives me 36. Not in the correct form, so now I have to divide everything by 36. And I get y minus 1/3, the quantity squared, minus, and I have y minus 3 squared, and this should be over 1, and this is over 36, is equal to 0. Not 0, 1. This is equal to 1. All right. Now I am ready to graph this thing. My y is the positive 1, so my transverse axes will run parallel to the y-axis. My center is 3, 1/3. Remember, my h's still go with the x's, my k's still go with the y. It doesn't matter who's first and second, it's still true. So I'm going to go to positive 3, 1, 2, 3, and positive 1/3. I'm going to exaggerate this. Obviously, that is not drawn to scale. So there's my center. My transverse axis is going to run in this direction. So from my center, I'm going to go up 1 to find my vertex. So here's my vertex. My vertex is going to be 3 and 1 plus 1/3, so 1 1/3. And my other vertex is going to be down here, which is 3, and then 1/3 minus 1 is negative 2/3. All right, so I found my vertices, and from the center, I'm going to go out 6 in each direction for my box. So I'm going to come out here to about 9. I'm going to come over here to about negative 3, and so this is negative 3, and this is 9. So now I'm going to draw my box. Obviously not drawn to scale. Draw my asymptotes from center to center, through, or corner to corner through the center. Now my shape is going to look like this. It's going to come along the asymptotes, touch at that vertex, and go back along the asymptotes. Along the asymptotes, touch, and go back out. I have found my center. I've found my vertices. I still need my focus. My focus is going to be c squared is equal to 36 plus 1. So c is equal to the plus and minus the square root of 37. So my foci would be here. It would be 3, and then it would be 1/3 minus the square root of 37. And then up here, which would be 3, 1/3, 1/3, not 1 1/3, 1/3, plus the square root of 37. Now all I have to do is find my asymptotes. So I'm going to go, here's my delta x. It is equal to 3. My delta y. Now my delta y, if we come back over here, my delta y was 1. So my y is equal to plus and minus 1 divided by 3, x minus my h part of my center, plus whatever my k part happens to be 1/3, and there is my asymptotes. And I'm totally fine if you leave it like that for me, because that is the asymptotes. Let's take a look at C and D here. Same kind of thing. So I'm going to go ahead and have you do these, and then I'm just going to give you the equations, and hopefully you can find that on your own. So for C, the equation that I got in standard form is it is y, because a y is positive, so it'll be first. Y minus 1, the quantity squared, over 4, minus the x minus 3, the quantity squared, over 9 is equal to 1. From here you can tell the center is 3, 1. You know your vertices are going to be, because this is transverse axis, it's going to run parallel to the y-axis. So it will be 3, 3, and the other one would be 3, -2. -1. Your foci, we have C is going to be equal to the square root of 13. So your foci should be 3, 1 plus the square root of 13, and then also 3, 1 minus the square root of 13. And then your asymptotes are y is equal to, you want to change in 2 over 3, so plus and minus 2/3, x minus 3 minus 1. And so there is all of the parts, just the graph is missing, and hopefully you can do the graph. Now, this one, of course, you had to move everything over, and your equation is x plus 4, the quantity squared, over 4, minus the y plus 1, the quantity squared, over 4 is equal to 1. Your center is at -4, -1. Your transverse axis is, of course, running parallel to the x-axis. And so your vertices are going to be -2, -1, and the other one should be -6, -1. To find your foci, this is going to be the c squared is going to be 4 plus 4, which is 8. That means c is plus and minus the square root of 2 root 2. So your foci are -4 plus 2 root 2, -1, and -4 minus 2 root 2, -1. Now your asymptotes, so we know that we have your slope should be plus and minus 1, so y is equal to plus and minus 1, x minus a minus, so it becomes plus 4, and then plus that -1, because it is literally the m x minus h plus k. So I just want to make sure that up here I have this should be a plus 1 there. Yeah, that should be a plus 1. Just so you know, this should be a plus 1. I'm going to make sure I have a plus 1 there. And then my center, so that was the only one that I did not have correct. Okay, cool. So eccentricity. So for hyperbolas, we want to talk a little bit about eccentricity again. The eccentricity of a hyperbola at this point, not in polar form, is still going to be c divided by a. For a hyperbola, c is always bigger than a, so my eccentricity is always bigger than 1 for hyperbolas. If my eccentricity is close to 1, the hyperbola appears to be very narrow, and as eccentricity increases, the hyperbola becomes very wide. So when it's in this form, this tells me, because it's c divided by a, c is 5, a is 3. Now pay attention to my vertices. My y did not change. So if I were to draw where these two vertices are, I have a positive 3 and 7, and I have a negative 3 and 7. So this tells me my transverse axis is in this direction. Halfway between these vertices is going to be my center. So my center is going to be right there. My center is the point 0, 7. I also know that since it's running parallel to the x-axis, it's going to be x minus 0, the quantity squared, over something minus the y minus 7, the quantity squared, over something is equal to 1. All right. Now, this confirms that this distance here is A, and the A is 3, and that distance is 3, so we know that this is going to be 9. Now all I have to do is find my B value. C squared is equal to A squared plus B squared all day long. So C squared minus A squared is equal to B squared. So I have 25 minus 9 is equal to B squared. And that tells me that this must be 16. And that's the equation. Now let's take a look at the next example. My vertices, again, I'm going to draw a quick picture so I know which way I am going to roll. And so I have my vertices at -1, 3. So -1 and +3, and also -1, 7. Oh, -1, 7. So my transverse axis is going in this direction. Halfway between these two are my center. So right here is my center. That means it is -1, comma, well, the difference between 7 and 3 is 4. Divide that by if I just add them together, I get 10 divided by 2 is 5. So here's where my center is. Bam, found my center. So it's going to be y minus 5, the quantity squared over something, minus x plus 1, the quantity squared over something, is equal to 1. Now I just have to figure out all of that information. Well, I know what my A is, right? My A is the distance from the center to a vertex, and I traveled a distance of 2. So that tells me this must be a 2 squared, or in other words, 4. So I found my A. Now remember, my eccentricity, my E, is equal to my C over A. So C over A is equal to 4. But we also happen to know that this has to be C over my A happens to be, by the way, my A happens to be 2. Because A is the distance from the center to a vertex, and that's 2. So in other words, C, not E, C must be equal to, solving this portion, solving for C, I get 8. So chasing B is what I'm doing, and so I have C squared minus A squared is equal to B squared all day long. C squared is 8, so that's 64, minus my B squared, which is 4. That tells me my B squared must be 60. So that is 60. Now we're going to look at the asymptotes. So you're going to see some of this on their homework. You might even see it on the quiz or an assessment. What I know is the first thing I'm going to do is figure out where my vertices are, and so I can determine which way I am orientated. So I always draw a quick sketch. I have -8, -1, and then I have 2, -1. So here's 2, -1. So this tells me I'm running parallel to the x-axis. That's my transverse axis. Halfway between these two, so I've traveled a distance of 10. Halfway between these is where my center is. So basically, I'm going to take -8 plus 2, divide by 2, and this is going to tell me where my center is located in the x direction. And we know the y direction happens to be -1 because it didn't change. So I get -6 divided by 2, which is -3. So my center is located at -3, -1. I also know my transverse axis is running parallel to the x, so it's going to be x plus 3 over something minus, and that's squared, and then y plus 1, the quantity squared over something, is equal to 1. All right. Now I'm going to pay attention to my asymptotes. I already know what my A is. In fact, I can tell you what my A is. A is that distance I traveled, divided by 2. I traveled a distance from vertex to vertex. I traveled a distance of 10, divided by 2. That means my A is 5, so that's 25 here. So I've got that part of it. Now, my slope is positive and -1/5. If I were to come over here and draw my box, here's where my center is. I would draw my box however it would look, right? And from center to center through the origin. Now, I know that this part of the slope is my delta x, and this part of my slope is delta y. So I know my slope is delta y over delta x. I also know this is going to be 1/5, because that's what it is here. I also know that the distance from the center to that vertex, or where I start counting to the edge of the box, is 5. So that I know delta y over 5 must be 1/5. So that tells me my delta y has to be 1. That means 1 goes here. All right, let's take a look at my last example here. So once again, I like to draw my vertices or whatever is given to me so I know the orientation, so I know who's positive and who's negative. -3, 10, so here's -3 and +10, so -3, 10, not drawn to scale, and -3, -2. Oh, so -3, -2. This tells me my transverse axis is going in here. This also tells me if I do 2 plus a -10 plus a -2 divided by 2 is going to give me 4. So my center is going to be -3, 4. So my center is -3, 4, right about there. Not drawn to scale. Now, my transverse axis is running parallel to the y-axis, so I know it's going to be y minus 4, the quantity squared over something, minus the x plus 3, the quantity squared over something, is equal to 1. The distance I have traveled from -3, 4 to -3, -2, or -3, 4 to -3, 10 is 6. So that is going to go underneath my y. So I've got that. Now, if I were to draw the box, right? So if I were to draw the box, bam, bam, boom, 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 bam, I had to have gone out some distance b, and I would have drawn my asymptotes going corner to corner through the center. There, I know that this is my delta y. My delta y also happens to be a, so that happens to be 6. This is my delta x. My delta x also happens to be my b value. Notice my slopes are 1. So my slope, which is delta y over delta x, is equal to 1. But I'm going to write it as 1 over 1, which is equal to my delta y is 6. My delta x is unknown, but the only way for this to happen is if my delta x is the exact same value as my delta y. So this is also over 36. And that's it for this video.